Hi guys, so this week we're just going to be reviewing trigonometry. We're kind of just going to go over SOHCAH TOA, so sine, cosine, and tangent. The reason we're just going to go over this for this week is because it is something you'll use when you're in Integrated Math 3 next year. So it's kind of just useful to brush up on it, so re-jog your memory a little bit. So hopefully you remember it. You really only need to do this video if you need the reminder. This video is not required, just to help you remember. So this is the right triangle. So remember there's 3 sides to it, and they all have specific names. So the one, remember, directly across from the right angle, that's the hypotenuse. And then remember, this is called theta. That's your unknown angle measurement. And you have adjacent and opposite, and it depends on where theta is. So since this side is directly next to theta, this would be adjacent. And again, that's because it's right next to theta. So then this side, since it's way on the other side of theta, this would be the opposite. So we're going to go over the functions, like how to set them up. And let's start with sine. So remember, you abbreviate sine just by SIN. So sine of theta is equal to opposite, I'm just going to abbreviate it, over hypotenuse. And then cosine of theta is adjacent over hypotenuse. And then tangent is opposite over adjacent. So those will be there to help you. And then remember, we used to call it SOHCAH TOA. So tells you which sides go for which function. So we're just going to quickly go over how to find a missing side and how you find theta. So remember, it doesn't tell you what function to use specifically, so you have to figure that out on your own. So you're given theta. So this is theta. And then this x is away from the theta, so this would be our opposite side. And then directly across from the right angle, that's always your hypotenuse. So once you have those 2 sides labeled, you say, okay, which function uses opposite and hypotenuse? And that would be sine. That's how you know that you're going to use this function. Oops. And then you just plug everything in. So sine, our theta is 60. And then opposite, which is x in this case, over hypotenuse, which is 18. And then now to solve for x, all you have to do is put this over 1, and then you cross multiply. So now I would have 18 times sine of 60. So this is all being multiplied. And then 1 times x is just x. So now, since x is by itself, that means you just can type this in your calculator now. So I'm using that Desmos calculator still. This is like the best one. The app for it is on the agenda. So I'm just going to type 18 sine of 60 and round it to the nearest tenth. So 15.58, that would round up to 15.56. There's your answer. So hopefully you kind of remember that. Okay, let's look at this one. So this is our theta, the 70 degrees. And then since this is right next to theta, I know that's my adjacent side. And then we're given the hypotenuse again because that's the side directly across from the right angle. And so which function uses adjacent and hypotenuse? So you look up here and you go, oh, cosine. So I have cosine of 70 equals x, because that's my adjacent, over 14. And I'm going to do the same thing. I'm going to put it over 1 and cross multiply. So that would be 14 times cosine of 70, and 1 times x is just x. So since x is by itself, that means I could just type that all into my calculator. So I'm just going to write 14 cosine of 70. And that's going to give me 4.78. So that would round up to 4.8. And then one more, because this one's going to be a little different. There's going to be one more step. So same thing, first you want to label, so I know this is theta. And then directly across from it, it's away from theta, that's your opposite side. And then since this side is right next to theta, that's your adjacent. So then the function that uses opposite and adjacent would be tangent. So I know I'm going to use that one. So it's tangent of 54 equals opposite, which is 10. Sorry, that O is in the way. Over adjacent, which is x. So do the same thing, put it over 1. So now x is being multiplied with tangent of 54. And then 1 times 10 is 10. So now, since the variable isn't by itself, I have to get the tangent of 54 off of it. And since these are all multiplying, you have to do the opposite of multiplying, which is dividing. So I'm going to divide this by tangent of 54. And that cancels. And then I do the same thing over here. So then I'm going to just type it all in. So 10 divided by tangent of 54, so it'd be about 7.3. So that's how you find the sides. Now I'm just going to quickly go over how to find theta. So remember, this is where you use the inverse function, where it's like raised to the power of -1 or whatever. That's how we know it's the inverse. Cross out number 4 because that's another side measurement as a typo. Okay, so this one, so if you notice it's a question mark for the angle, that's because we're looking for theta. So you still want to do the same thing, you're labeling what sides you have. So I know for sure this one is the hypotenuse. And then since this side is away from theta, I know this is the opposite. So the function that uses opposite and hypotenuse is sine. So I'm going to write sine of theta, because I don't know what it is, equal to opposite, which is 51, over hypotenuse, 55. So then remember, you're kind of getting the sine off of theta, so you have to do the opposite of sine, which is the sine inverse. So it would be theta equals sine inverse of 51 over 55. So this app has that. You just have to go to function and then you'll see the inverse. So sine of negative, or sine inverse, and then you have to go back. 51 divided by 55. And it'd be to the nearest whole degree, so it's 68 degrees. Oops, sorry, you can't really see. Okay. So I'll do this last one. So again, we don't know what theta is, so you want to label. So since this side is right next to theta, that's how it's adjacent. And then this side is away from theta, that's the opposite. So the function that uses O and A, TOA, which would be tangent. So tangent of theta is equal to opposite, which is 16, over adjacent, which is 7. And then again, since we're looking for theta, you have to do the opposite of tangent, which is the tangent inverse. So tangent inverse, 16 over 7, and then just type that in. So you have to go to function, press tangent inverse, and then go back to main, 16 divided by 7, and nearest whole degree would be 66 degrees. So that would be what theta is. So hopefully you guys remember how to do this. It's been a very long time, but knowing how to do this will be helpful for you in Integrated Math 3 next year. So let me know if you have any questions, and hope you guys are doing well. Bye.